Now, ladies and gentlemen, well, property standards for an accelerated deployment of CCS. I'm chair of thermodynamics at Ruhr University in Bochum, and thermodynamics, my group in Bochum, is working on different fields. So in total, something like 6 areas we're working on, but most of these areas are rather small, just 1 or 2 PhD candidates working on them. The areas which are by far the largest and which we are known for internationally are the accurate measurement of thermophysical properties and the accurate modeling of thermodynamic properties. So those of you who know me, well, know either talks about our Helmholtz equations of state, our empirical multi-parameter equations of state, and then you are treated with equations like that. You may have been more lucky and have heard a talk about experimental work. Then you heard a lot about densimeters and speed of sound measurements and whatever. That's the usual talks you may know from me, but today is not a usual talk. Today it's an award lecture, so no nerdy talk today. Today I dare to share some more general thoughts with you. And I say dare because that's a risk, of course. If you share general talks, you talk about things where you aren't really expert in the common sense. So we will see how this works. Now let's just replace the property standards by measures to become more general. Where are we? You have seen yesterday and today we have seen a lot of projections into the future, and we have different scenarios. We may go along. What we know pretty well is where we are. And where we are is we see that, well, the developed economies, well, for the developed economies, we can say that the increase in CO2 emissions has stopped. So all developed economies, the CO2 emissions are slightly decreasing. Even China, the steep increase we have seen in China in the first decade of this millennium is stabilizing its CO2 emissions. The only large emitter which is constantly growing over the last 2 years is India now. But nevertheless, if we look at the global emissions, we see that we still have an increase in CO2 emissions. And this is due to an increasing share of the developing economies, something we cannot and we don't want to deny because that's coupled to the economic development of these countries. So the consequence is, in my view at least, that the developed economies fail to drastically cut their emissions. And we also have to say that CCS fails to contribute. So we do have a number of pilot projects, we have large pilot projects, but you all know that we are not yet really on a commercial level, and contribution by CCS is much smaller than we thought. Now, why does CCS fail to contribute? I think, as probably most of you, that capture technology is ready. Particular post-combustion capture seems to be mature. There are other technologies, pre-combustion capture, oxyfuel, chemical looping, carbonate looping, and just to name a few, which are ready to apply at larger scale. They may not be commercially ready, but they can be applied and can be developed soon. So we know that CO2 transport can be handled at large scale. And storage, we have heard a lot about, is in principle proven technology. So it's not really technical hurdles we have. The hurdles we have are on a different level, and you all know them. Yet we have no business case for CCS. The perception by NGOs and in the public is critical. At least I can tell that for Germany. We have heard different from Bologna yesterday in the evening. But I don't think that German NGOs would sing that song. And we know that the legal framework is critical. We have heard about that yesterday too. So we are in a situation where politicians hesitate to really support CCS, because the whole framework is critical for them. It may cost votes rather than bring votes. So that's the problems CCS, well, which are, in my view, at least responsible for the fact that the CCS deployment does not go ahead as fast as it could. I briefly looked through the program of this conference, and we have something like 25% of talks where, just from the title and the abstract, I would say it's not purely technical talks. So that's good. That's much better than it was 10 or 15 years ago. So the share of non-technical presentations is increasing, but it's yet not high enough. And if you look closer, many of these talks are still given by technicians who then adapt to other areas and talk about economic issues. We need to get other colleagues involved. We need to get economics involved. We need to involve macroeconomics, people who really prove that solutions with CCS are on a national scale, on an international scale, more efficient than solutions without, say, CCS. We need to involve social science. We need to include law schools and political science. We really need to get them on board, more than they already are. Of course, there are a few, no doubt, but not yet enough. And just to use Ruhr University as an example. So Ruhr University is a comprehensive university, a rather large comprehensive university with something like 20 faculties. At Ruhr University, we introduced research departments as kind of a cross-cutting instrument for interdisciplinary research. And something like 2 years ago, we established a research department, Closed Carbon Cycle Economy, which includes colleagues from 10 different faculties, really going from applied philosophy to natural science and engineering science. And of course, well, introducing such interdisciplinary organizations makes sense for us as technicians and natural scientists as well. But one of the main reasons for the introduction of this research department was to get faculties, colleagues involved, which are not yet involved in the discussion of closed carbon cycles. And if we talk about closed carbon cycles, we as a CCS community always have to have in mind that CCS most likely is a necessary element of this development, but CCS is not the solution. So the discussion needs to be much broader than only on CCS. CCS is an element. And this is particularly important if we involve social science and humanities. So when we talk about social science and humanities, we very often talk about things like public perception and maybe more directed into public relation. How do we communicate our messages? But actually it's much more. We are talking about the development when we think about closed carbon cycle economies, which takes 30, probably more likely 50 years. Think back 50 years. 50 years ago, I just came to elementary school. The house we were living in was probably 3 times less energy efficient than the house we live in today. But its area was much smaller. And we had no computers. Our lighting system was less effective. We had no computers. We just bought our stuff in shops. We didn't deliver it by Amazon. So, and international air traffic was restricted to a very small community, which we called jet set. So the society has completely changed. And if we today talk about development which goes 50 years in the future, I don't know what the society will look at that point, but I'm sure it won't be the society we have today. So we need to include social science and humanities not only for public perception, we need to anticipate the developments our society will take if we really want to come to reasonable projections into a future 50 years ahead. So that's much more than social acceptance. Now, talking a lot about social science, law schools, things like that. What can we do as technicians? When I assume most of you are technicians just like me in some way. Now, if we really want CCS to contribute by 2030, let's just say 1% of our CO2 emissions. That's less ambitious than most scenarios we've seen, but 1% would be a start. 1% means that we need to store something like 370 megatons CO2 a year on the emission basis we have today. Large power plants emit something like 5 megatons per year. Most industrial sources are smaller. So we are talking about something like, say, 75 to 400 commercial projects we need to establish the next 10 years if we want to reach 1%. Now, from my view, rather optimistic projection would be that we have something like 2 to 5 full-scale commercial projects which start, let's say, next year. Typical duration of such a project is 5 years, from detailed planning to actual operation, at least on a German scale. I don't know whether your approval processes are faster than ours, but in Germany, things like that take 5 years, at least. Now, it's not very realistic that we have something like 5 projects starting next year, and then we gather the experience from these projects, and when we have these experience in 5 years, we start the other 250 projects or something like that. That won't happen. So if we want a development like that, we need to have an increasing number of projects starting very soon. And to come to such a development, we need to have commercial full-scale projects starting in as many countries and as many regions of the world as possible, almost simultaneously. And the problem is that depending where you start these projects, you will have to deal with different authorities, different national authorities, different regional authorities. A project that's approved in Norway or the Netherlands is not automatically approved in Germany. So the problem, in my view, is that we don't have established technical standards yet, because the only way really to get systems or to get projects approved on a halfway reliable basis is if you have established standards which you can refer to in the approval process. And this is, in my view, particularly important if we talk about transport and storage. So capture requires standards as well, no doubt, but capture will take place on industrial sites. So that's, for authorities, capture is pretty similar to approvals for chemical plants. And there are established rules, and probably difficulties will not be too high. That's different if you talk about transport, particularly pipeline transport or storage. We have heard about the leakage discussion just a few moments ago. We have the same problem if we have pipelines. Don't know how much problems we will have with ship transport. It's probably easier to get approval for ship transport than for pipelines. But if we want to get that approval halfway fast, we need standards. And now, luckily, there is already an ISO committee working on standards for CO2, capture, transport, and storage. This ISO committee has the 6 working groups. And myself, I'm not part of this ISO committee. I know that a few members of the committee are among us. It's not me. The committee works on different topics: capture, transportation, storage, quantification, cross-cutting issues, enhanced oil recovery. So this is a good basis to start with international standards, because what we don't want to have is different standards in each country. That doesn't help. In the European Energy Research Alliance, I'm responsible for the area of CO2 transport. And that's why I looked closer at the existing ISO standard for CO2 transport, for pipeline transport. That's ISO 27913, established 2016. And if you look at this standard, you realize that it addresses, I would say, the most important issues with regard to transport. So properties of CO2 and CO2 streams are addressed, mixing of streams is addressed, general design concepts and criteria are addressed, materials are addressed, construction, operation, even the requalification of existing pipelines. And if I look now into the area of my expertise, now the standard gives reference to the Gerg equation of state as one possible property model, so the natural gas equation, which also covers CO2, and it refers to some newer models, particularly for CO2-rich mixtures. So that's exactly the references I would have given 2016. So that's all right. The reference is not very explicit, but it is given. However, if you look through the standards, you realize that it addresses all the questions, but it doesn't tell how to calculate. And that's the problem. So the standard leaves too much room for different ways of calculation, and therefore too much room for discussions with authorities. I'm sure we can do better than that if we combine our expertise. Just one brief example now from the area of my competence. If we combine CO2 streams in a pipeline grid, we can calculate densities of CO2 pretty accurately. So if we measure volume flows, we can deduce mass flows from these volume flows. That works with high accuracy. If we want to share not only the pipeline, but also the separation plant, the situation is different. So we are talking a lot about hydrogen, blue hydrogen. So this implies that we have CO2 hydrogen mixtures at some point before we separate. At that point, we have deviations in the order of 1%. And, well, looking at the timing, I want to cut that short. 1% deviation in density means that we run into typical allocation problems if we want to share infrastructure. So 1% in density means 5% difference or deviation in the bill in the end, and that will not become a lucky business relationship. So this is just an example for we can tell what we can do. We can define standard cases where our methods are already good enough to design systems, and we can also define cases where we aren't yet at that point. As scientists, we very often focus on the issues where we have open questions. That's, of course, our interest. But we need also to define the cases where we can establish standards and where we can help to simplify approval processes for standard cases. And I think only if we do that, we have a chance to push ahead this fast development of CCS we need. Without standards, all the approval processes will take far too long, and we won't see the necessary increase of commercial projects. Thank you for your patience.
Thanks a lot, Roland, for a very interesting lecture containing very many different approaches like social sciences and humanities involvement in CCS. I think it's very important what you address there, and also the technical standards is also very interesting. I see that the time is a little bit limited, but one question, a very important question, is coming up there.
Thank you for your lecture. On your statement of development of standards, I do agree that we need to standardize and we need to develop standards. But I'm a little bit concerned that we are not acting fast enough because we need to wait for development of standards and laws and legislation. So I would advocate that we should get started with the CCS and also develop standards as we go, because as we've learned, CCS is safe by design, and therefore waiting for committees who don't work necessarily very fast is not, in my view, a recipe for getting the take-up that you also advocate that we need. So that was more a comment than a question.
Yeah. So my message was clearly not wait for standard before you start the first projects. Of course, this needs to be developed in parallel. But my point is that we need to see this large increase in the number of projects which are developed in parallel. And as long, in the next years, as long as we develop 5, 10 projects worldwide, that can be managed without standards. We have the expertise to do that. But if we want to develop 100 projects in parallel, we are run out of experts. So, and if we want to come to that point, we need to have standards established.
Thank you very much.